I now again only have HPC2N and UPPMAX and Tetralit because my connection to Cosmos somehow timed out and crashed. So I need to log in again to there, but let's just go with this for now. Okay, I'm going to talk about running Python in batch mode. What are the UPPMAX, HPC2N, LUNARC, and NSC clusters? What is a batch job? And how to make a batch job are the questions. So I will give a short overview of the HPC systems. It will be short because we already mentioned it in the very beginning of the course. A short intro to the SLURM scheduler, a structure of a batch script, and then an example for you to try. So again, there are these project IDs or computer allocations for the workshop. There's one for Rackham, one for Kebnekaise, one for Cosmos, and one for Tetralit. There may be a question. Can someone check on the chat? These you will need to put into your batch scripts. There is storage space on the workshop. We already talked about this. They are different for each center, partially because they are simply named differently, partially because the path is different on the centers, but you find them like this. And it's only one of them that will be relevant for you. So there are also reservations on UPPMAX and on HPC2N. That is in order for you to get your jobs to run a little bit faster if there's a lot of people using it. So they can be added, and you add it with hashtag sbatch -- reservation and equals the reservation name. And the reservation name is any of these. So today it's this for CPUs and this for GPUs. It goes to one AMD Zen 4 node and one NVIDIA L40S GPU node on an AMD. The ones on UPPMAX are magnetic. That means it follows the project ID. You don't have to add the reservation name. So this is only if you're on HPC2N and only if you feel that it's not starting quickly enough. Quickly about cluster hardware and the systems. What's a cluster? Login nodes and compute nodes. You log into the login node. The batch job are sent off to the compute nodes. Network of computers. Each computer is a node. Each node has several processors and RAM and also local disk. I'm not going to go into this much. You log into the login node either with SSH or thin link or some other way. And if you have heavy jobs, long jobs, some that use lots of resources, they have to be done on the compute or calculation nodes. And this is a link to documentation at HPC2N. There are similar at all the other centers. Things in common. They have Intel, most have Intel CPUs. HPC2N also have some AMD CPUs. Linux kernel on all of them. Bash shell on all of them. The shell is only relevant insofar as Bash is only shell compatible with the batch system. So just know that we're using it. And that is just the way you're giving commands to in the terminal is relevant. But since we are using Bash in this course all the time, and that probably is usually what you find, then let's ignore it for now. So again, long resource-intensive parallel job, run them as batch scripts. The batch system on all these centers and most other centers are called SLURM. SLURM is an open source job scheduler, provides 3 key functions, keeps track of available system resources, it enforces local system resource usage and the job scheduling policies, and it manages a job queue, distributing the work across resources according to policies. In order to run a batch job, you must create and submit a SLURM submit file. When you Google SLURM submit files, you will find they can be called many things. Batch submit files, batch scripts, job scripts, and other things. It's the same. Here are links to guides and documentation on each of the centers. So the workflow, you write a batch script. In the batch script, you tell it to load the modules you need. You activate any virtual environments, isolated environments that you may need if you have installed packages yourself. And you ask for resources depending if it's a parallel job, serial job, you need GPUs, etc. You tell it how long to run. And then if you have commands to a Python script, you give them. And then you submit the batch script with sbatch and then the name of it. You can call it what you want to. You don't need the extensions .sh or .batch. It's just a convention. So just name it something that makes sense to you and something you can easily find. It's a short cheat sheet of useful commands. You submit the job with sbatch and the job script. You get a list with sq minus u, your username. You check on a job with scontrol show job and the job ID. Delete a specific job with scancel and the job ID. You can also delete all of them, all your jobs that is, with scancel minus u and your username. You can also get a list of your jobs with just sq minus minus me. This will give useful info about the job, like how much memory it uses. And this will give you a URL to a page with info for the job. And it only works on Kebnekaise, but it will give you a URL you can put into a browser, and then you get a graphical representation of the resources used by your job. And I will show you these commands in a very short moment. So example Python batch scripts. We will look at serial code because it's the simplest example. And you could type along here. In this, I will run this one named run underscore mmmult.sh. It's a matrix multiplication. It can be found in these directories here on each of the centers. You go to exercises, to examples, and then you go into the one for the specific center. So if it's HPC2N, you go in there. If it's UPPMAX, you go into that. And the same for Cosmos or Tetralit. So I will go to exercises. Where am I? I'm not inside of my directory. This. Okay, and inside of that you have these batch scripts. And the one we're going to try and run is this one here. And it looks like this. It's very similar. The only difference really is the project ID and then the modules that you load. So first, there is this sort of incantation. It tells the batch script they run it in the bash shell. Irrelevant other than the fact that it's the only one compatible. Just put it there. Then you ask for what project ID you will run in. All the commands in a batch script are prefaced with hashtag sbatch. It has to be capital letters. -A is the account or the project ID. You put it here. Later, after the course, you change it to your own. This will be valid for most of the rest of the month, I think, at least a few weeks, so you can test run the things later. Then you ask for how much time you should use for your job. With either -t and the time or minus time equals hours, minutes, and seconds. at most 1 week. It's worth thinking about how much time you ask for. You should ask for as much time as you think your job will take, but no more, or at least not a lot more. It will take longer for a job to start if you have asked for 1 week of time than if you have asked for 1 hour. So if your job in reality takes 30 minutes, don't ask for 1 week, because then it will sit in the queue and wait for a slot of time to be available for a whole week. But also don't ask for too little, because when this time is up, the job ends, whether or not your job has continued running. So in this case, I'm going with 10 minutes. It's probably a lot too much, but just as something. I'm then asking for 1 core. It's a serial job. Then I load the modules I need. On UPPMAX, I just need Python 3.11.8. On HPC2N, I also need the prerequisites of Python, and I need the SciPy bundle because NumPy is there. The same is the case on LUNARC and also on NSC. This is how this program looks like in Python. As you can see, it needs NumPy. Okay, so let's try run it. I will submit it with sbatch run underscore and then this here. So it's here. I will say sbatch to run it. And right now I will do that on each of these centers that I am logged into. Do it as well on, I'm just not logged into Cosmos right now. But as it is running, you can do SQ-U, your username. If you can spell it, it's different at the center than the others. It already ran. Let's submit it a couple times more. Minus. Why is that not working here? Because I had a space. But you can see here, I'll just make this a little bit wider so you can see it here. The job ID, I will try show here. I will again submit a job. And then you see this is the job ID. You get it when you submit it. It's also listed here. So if you have several jobs, they will all be listed here. This is the partition it runs in here. It's not relevant. There's only a default one. It will have a name, which is by default the name of your submit script. You can name it inside of your batch script. It could be useful if you submitted a lot of jobs and you want to see which one it is that is running and where. It tells you your username. You already know it, but it still lists it. It tells you the state. The state of the job is right now pending. It could be running, or it could be completing, which was CG. It can also be held and a few other things, but these are the more common ones. It then lists how long it has run, how many nodes, or rather cores, it's running on, and the list of nodes it is running on. Here it is not yet assigned one, since it's pending and no time has passed on the running. Here it was running, so it has started to run for some time, and it had a node. There is also scontrol show job and then the job ID. It will give you more information. In this case, the job state was failed, and that was because I neglected to add everything here before I need to check inside of it in a moment, but I just want to show you here. It shows you the project ID. It shows you the runtime, which was 14 seconds. It shows how long it was allowed to run, which was 10 minutes. and it tells you when it was submitted, when it started to run, and if it had not yet started to run, then there would also be one for estimated start time or expected start time, which can change depending on other people submitting jobs and their priority. It also lists which nodes it ran on, how many cores, which if it had like GPUs, only CPUs, and how much memory it could use. And it also lists where this submit file was located, where you have your working directory, and a lot of things. So this is useful, but usually SQ --me gives you enough information. But one thing it also gives you is a list of your job IDs that you could then use with S-control show job ID to see more of your jobs. I'm just going to submit a bunch of jobs so that I can show you some things. And here you can see it is pending most of the places. And it's a very short job, it already ran. So let's try submitting it again, mainly so I can do S-cancel and -u and my username. That means it cancels all the jobs and then nothing is running. So yes. And when you do this, run a job here, when you haven't named the output files, it will create an output file named SLURM minus the job ID .out. Okay. There is an example here of how to run if you are also using a virtual environment. The only thing that is important there is that you source it. First, you load the modules, then you source this path to the virtual environment /bin/activate, just like you would do if you activated your virtual environment on the command line. So you just do that inside of your batch script, and then you have access to these packages you have installed in the virtual environment. And then you run your Python script. If your Python script needs arguments, you cannot give them to it while it is running. You have no interactive mode here. That means you would put them here after the project, after Python, your script, and then you would put the arguments. So there's an example here about how you could use job arrays. This is a simple Python script, and if you wanted to use job arrays, you do it like this. Since we're not going to use that today, I'm just going to go quickly past these. So we will have time for also looking at interactive work and the IDEs. This is an example of an MPI code. The important thing here is you will ask for more cores, simply. That is the main thing. There is a lot of stuff here written, but that's mainly to say how you install MPI for Pi in a virtual environment if it's not existing on your system already. A GPU code, that is important for this here. And here's a short GPU example for running compute.py on Snowy. And you could run it interactively, but here, this is how we are running it as a batch job. And here, since Rackham, the one we are logging into, do not have GPUs, we are telling it to send the job to Snowy, which has GPUs. And we only were asking for one GPU here. Then we load the Python 3.11.8. And if it's an ML job, then you are asked for the Python _ML_packages for the version minus GPU because you want the GPU version of them, and then you run the job. On HPC2N, you tell it how many GPUs you want. I will talk a little bit more about that in the using GPUs with Python. It depends on how many GPU cards are on the specific type of nodes, and in HPC2N, there are many different GPUs. But in this case, you ask for one GPU and you say, I constrain it, I only want the V100s. You could also choose other ones. Again, we'll talk about it. Then you load what you need. In this case, I want to use number, and I also need NumPy, which is in SciPy bundle. So I load those. On LUNARC, it is almost the same. I load similar modules. But here I am asking for GPUs by saying -P for partition, GPU A100, and then I want one GPU. And on NSC, instead, there's only one type of GPUs. You just say minus GPUs per task equal how many, and you want one here. And then you load the modules. So there are small, subtle differences between the centers in how you load the GPUs. So just look at the center that you are working at and see how you are asking for a GPU. Then you load the modules. Remember, it's important that it's modules that can actually use GPUs. And in this case, I would be using a virtual environment with number in it. And there is one here that we have created on NSC. I'm just going to show you. It is in this top directory, the storage directory itself. There are some virtual environments there, as Björn said. There's one for TensorFlow, one for PyTorch, there's one for Number, and some other ones. In this case, if you wanted to run this Number example, you would use this one here. So you would write source and then the path to the project storage, and then this virtual environment, and then bin, and then activate. And you can see it then activates this environment. If I now start Python and I import Number, it is there. It just needs a moment. Yes, as you can see, it's there. So I'm going to deactivate this again, because this line here, you will put that inside of your batch script if you are on NSC. So I will go to my directory here again, where I had the exercises, and I will go into NSC. I will open this run, I can't spell, sorry, compute. And I will check it has the right project ID for Tetralit. I am setting the path because the programs are in another directory. That is what this line does. It just tells it that, and I need to change this here to my name. So just put the name you created your directory with here, and that is why my other job failed, because I hadn't done that, so it couldn't find it. Then you load these, and then you add this line that I just copied, and I already put it here, as you can see. Okay. And that means that this should now work. Let's see. See if it's running. It is pending for resources. So that means that I'm going to start it on some of the other centers as well, meanwhile. Because this I think that you should all do. So there's an example that we should all do, just to see that it's running. And I'm using VI. You should use Nano. I'm going to use Nano to do it on UPPMAX in a moment. And I should also write what I was wanting to write. It's pending there as well. Okay, let's do it like this here. So it's not too difficult to read. Where am I? I am in the right directory. I am going to open run compute here. And then I'm going to go down here to the path. I'm going to change it. Sorry, I promised I would use Nano. I will use Nano. I will go here and change this path here. Put in your own name here, the name you used for the in the storage directory. And this is the only thing that needs changing. So because of that, I'm going to hold down Control and press X. I will say yes, I want to save it. I will save it in this file. I will do sbatch. I will submit this job. And then I will see if it's running. And now here, I forgot to add -m snowy, which means that it told me if it was running on Rackham, which I know it's not. If you are checking if it's running on snowy, then you have to add -m snowy. And it's still pending there as well. Let's see if it has started anywhere. It has run on HPC2N. And you got an output file like this. Let's see if it worked. And it did. It just complained about some stuff, but it actually ran. And it is telling me how long it took with and without the GPU. So it worked. Okay. And I think that if you can get this to run, you should stick to that. There's an exercise. The only thing you need to do there is take this first example. Let's see if I can find it here. For running the matrix multiplication, and then instead change the script. So it takes this Python script where it adds two numbers. That script also exists here, and you can do it later if you want to, but I think we should continue because otherwise we're not going to get things done, and there's no real value in just redoing it for a different one. So you can do that later. So the key points, we know the SLURM scheduler handles the allocations to the compute nodes or the calculation nodes. Interactive sessions will be presented. It has been moved around here. Batch jobs run without interaction. Batch script consists of one part with SLURM parameters describing the allocation, and a second part describing the actual work, including which modules to load. Let's then go to interaction.